In activity 5.2a, we're given little g of x equals absolute value of x minus 1, and the capital G of negative 1 equals 0, and we're going to draw the graph of capital G given that initial condition where capital G is the antiderivative of little g. In other words, where capital G prime of x equals little g of x. Now, one thing that might help us, and you can do this with your graphing calculator, is to get an idea of what this graph of little g of x looks like. Well, it's the absolute value function, which is a v graph, shifted down 1. So it's going to look a little bit like this, and we're only going to look at it from negative 2 to 2. And it hits here at negative 1 and 1. And we're going to use this to help us draw the graph of capital G of x. So we'll draw some axes, and this will be our x. This will be our y for our function g of x. And we'll do this via accumulation. Now we know g of negative 1 equals 0, so we'll just let each of these be 1 unit. So there's our initial condition marked. Now we can do it as far as accumulation. So first off, let's go, notice here, this triangle is underneath the x-axis and has an area of negative 1/2, a base of 1 and a height of 1. So this is going to go down 1/2 as we go from negative 1 to 0. What about going backwards? This has an area of positive 1/2, and it tells us our function was increasing because it's above the x-axis, so it increased a half to get to 0. That means it was back here at negative 2, it was back here at a half also. Sorry, this is a little out of proportion. That should be a little more symmetric. Now, let's go to the other side, and we'll just assume this is a continuous graph, and I'll show you how we can make it continuous. We got another area of negative 1/2. That means we're going to go down 1. And then we got one more area of positive 1/2. So we're going to go back up a half. Now if we look at what's going on, increasing, decreasing, decreasing, increasing. So all that matches up. And also we got a max here, because there's our critical point, and it went from increasing to decreasing. Min here, critical point, decreasing to increasing. Same thing with the concavity. It's going to be concave down and concave up. There, and concave up here. Now what we're going to see is, to do the antiderivative, we actually have a couple of quadratics. What I'm going to do is little g of x equals the absolute value of x minus 1, but we could write that as a piecewise defined function. It's the graph of x minus 1 if x is greater than or equal to 0, right there, or negative x minus 1 if x is less than 0, which is this side. So now we're going to do capital G of x. So we're going to do the antiderivative of each of those. So we have x squared over 2 minus x plus, I'm going to call it c1 for x greater than or equal to 0. And here we have negative x squared over 2 minus x plus c2 for x less than 0. Now remember, we had an initial condition. G of negative 1 was equal to 0. So that means we're going to use this part of the equation because x is less than 0. So when x is negative 1, we have negative 1 squared over 2 minus a negative 1 plus c2. And we want that to equal 0. So we're trying to satisfy this initial condition. So we have negative 1/2 plus 1 plus c2 equals 0. Negative 1/2 plus 1 is a half, which means c2 has to equal negative 1/2. Further, notice what's happening at 0. These two pieces need to be equal for it to be continuous. So if we look at g of 0, basically that's going to be 0. That's going to be 0, 0, 0. we get C1 for x greater than or equal to 0, and C2 for x less than or equal to 0, and we need it to be negative 1/2. So not only does C2 have to equal negative 1/2, C1 also has to equal negative 1/2. So for the function we have graphed there, it's just a couple of quadratics in a piecewise. We have x squared over 2 minus x minus 1/2 for x greater than or equal to 0, and negative x squared minus x minus 1/2 for x less than 0. This is for the initial condition, specifically g of negative 1 equals 0. If we wanted to do another one, say we put in the initial condition g of negative 1 equals 1, that's going to vertically shift everything up by 1 unit, including our c value. So there would be our downward quadratic, here would be our upward piece, and we'd adjust our c. So in this case, everything got moved up 1. G of x would be x squared over 2 minus x, moving that up 1, just adding 1 to it, plus 1/2 for x greater than or equal to 0, negative x squared over 2 minus x plus 1/2 for x less than 0. And there we have a shift. And we could do that for any initial condition.